Hey everybody, welcome back to another video. Today we're going to be discussing the 4 different types of intermolecular forces from the Chemistry Unit 6 curriculum. And this is just a brief preparation video before the upcoming quiz, so let's dive into it. What are intermolecular forces? They're basically attractions between molecules, and they are weaker than covalent and ionic bonds, but they control boiling points, melting points, solubility, and viscosity. First, we have London dispersion forces, and they're present in all molecules. They are caused by temporary shifting of electrons, which result in temporary dipoles. Strength increases with larger molecules, more electrons, and greater surface area of a molecule. And these London dispersion forces come from the constant movement of electrons in molecules. At each moment in time, the electrons are in a different position, which cause different instantaneous dipoles, and that's where you get your London dispersion forces from. Here are some examples: noble gases, nonpolar molecules like O2, CO2, and CH4. And your example comparison is the diatomic molecule I2 has a stronger London dispersion force than the diatomic molecule F2 because it has more electrons, and this results in a higher boiling point. Dipole-dipole forces, they occur between polar molecules. Positive end of one molecule attracts the negative end of another. Again, here are some examples. And HCl molecules attract H because H is slightly positive and Cl is slightly negative. Hydrogen bonding. This is a special type of dipole-dipole force, and it occurs when H is bonded to one of the 3 most electron-negative elements in the periodic table, N, O, or F. There is a very strong attraction between the molecules. This is very similar to an ionic bond when you have the more electron-negative elements basically taking all the electrons from the less electron-negative element. And that's exactly what happens here. N, O, and F want to take hydrogen's 2 electrons, so they gain a negative charge while H gains a positive charge. And this is why this can also be seen as a dipole-dipole force, because NH, OH, and FH are easily bonded with other polar molecules. Here are some examples of hydrogen bonding: H2O, NH3, and HF. Water, ammonia, and hydrogen fluoride. Why water has a high boiling point? Strong hydrogen bonding between molecules. And let me just elaborate on that real quick. Temperature is proportional to kinetic energy. And as temperature increases, there is more energy being transferred into the water. And this energy is what allows intermolecular forces, intermolecular bonds to break, right? This is an endothermic process, as described in classes, where temperature increases the energy of these molecules where the bonds break, and this is why water has a high boiling point. It takes a lot of energy to break these strong hydrogen bonds. Ion dipole forces. Attraction between an ion and a polar molecule. Important in solutions. Example: Na plus and water, salt dissolving in water, KCl dissolved in H2O. I'm not too sure about this example, I just found it off of the internet, but you can never go wrong with your classic salt dissolving in water example. So key takeaways: stronger IMF equals higher boiling point. Polar molecules have dipole-dipole forces. Hydrogen bonding only with nitrogen, oxygen, or fluorine bonded to hydrogen. All molecules have London dispersion forces. Thank you so much, and subscribe. And also, if you guys want to set up any tutoring sessions with me, I'm more than happy to do so. Just make sure you fill out the form in my YouTube bio to set up a session with me at any time. Thank you so much. Good luck on the quiz.